Dear programming bro, I see you, I hear you, and I love you. Okay, so today I'm going to be bringing you a course you have not been waiting for. An introduction to the intellectual art of machine learning and data science. Okay, this is how much I love you. So today we're going to be discussing machine learning, the two types, focus on supervised learning. I will talk about the libraries that we're going to use, and by the end of this course we're going to build a machine learning model that takes in the Titanic dataset and predicts whether a passenger who was in the Titanic survived or not. Okay, so there are two types of machine learning, as you see here. The two types of machine learning, which is supervised and unsupervised machine learning. With supervised machine learning, we have a known target based on previous data. And then, as you expect, with unsupervised machine learning, there's like no known target. So today we're going to focus on supervised machine learning, which comes in two categories: classification and regression. Okay, so with regression, it is the type where we're trying to predict a numerical value. For example, if we're trying to predict a price of a house, okay, we're going to be predicting a numerical value, but it falls under supervised machine learning because we have data from previous houses. Okay, and then with classification, we're trying to predict category. Say, for example, a bank trying to predict whether a person will take a loan or will not take a loan. It still falls under supervised machine learning because, like, the bank has previous data of people, so it can have like past data to predict the future. So the libraries we're going to be using in these videos are pandas, numpy. We're going to do some plotting with matplotlib.pyplot, and then for the algorithm, for the model algorithm, whatever, we're going to be using one from scikit-learn. Okay, so what is pandas? Pandas is like a Python module that is used for reading and manipulating data, and then numpy is another Python module which is used for manipulating or computing on numerical value or on a numpy array, from computing numpy array. Maybe you want to find the mean, median, whatever, as we're going to talk as we get into statistics. And matplotlib, as the name suggests, this one is for plotting graphical visualization of your data, and then, as I've said, sklearn is where you will find your algorithm. So before we get into the machine learning, most people make this mistake of, when they're trying to learn something and they don't have enough knowledge about the background. I don't like that. That is why we're going to go into the intellectual art of statistics and the world of distribution before we go into the intellectual art of machine learning and data science. So say we have, like, I'm going to use the term array, although in Python they're called lists. I don't really use Python on a day-to-day basis. Like, the last time I programmed in Python was like in 2023, so my Python is sketchy, so I'm going to be using array instead of list. It doesn't make sense to say list. Okay, let's say this is an array of you guys' ages. Okay, the people, the students, ages of students who are watching these videos. This array, the data, they have a mean of 22, the median, which is the middle value. You guys know this. The middle value is the median, which is 22, and they are the median is known as the 50th percentile. You guys know this. Okay, you know this by heart. And then the other two important percentiles, which is the 25th and the 75th percentile. The 25th is one which 25% of the data is less than it, and then 75% of data is greater than it, and then vice versa with the 75th percentile. So the most important things in statistics are the variance. Two things in statistics are in this type of things, okay, on data, is the variance and standard deviation. They are quite similar because, like, the standard deviation is just the square root of the variance. But what are they? Okay, this is like the idea I want to plant into your head. So the variance and standard deviation, they tell us how spread out the data is from the mean. You will see when we try to find them, then, oh yeah, they're just telling us the distance, how spread out your data, how far away is like the data from the mean, the individual data points from the mean, how far away, and then we find the average of this distance. Okay, so to find the variance, what we do is that you go into your data set, you find the mean, okay, and then you go go through each data point, say 15, 16, you go through each and say 15 minus your mean, and then you store it, that's 8, and then you're going to use the absolute value, the absolute value of the value you're going to get to make it positive. Okay, you don't want to store a negative number. So like, and then 15 minus 23, that would be 8. Okay, and then 16 minus 23, that would be 7. Okay, so we take these values, we store them in the distance array, and then we square each of the value and sum them and get this value. And then when we divide this value by the number of edges in our array here, we get the variance. And then for the standard deviation, we just take the square root of 40.22. Okay, very, very simple. So if our data is normally distributed like the graph below, we know that 68% of the population is within one standard deviation of the mean. Okay, I assume that you guys have done distribution, because most of the people I'm going to share this with are from my school. So you know this normal distribution and what it means when something is one standard deviation away from the mean. So now we've done that, I'm just going to write a simple Python code to calculate the variance. So here we're using import numpy. I told you that numpy is a Python module for computing numpy arrays, for computing like this data in an array. So we found the mean and the variance. Let's just maybe print them out. Let's just say, like, see, the Copilot is on, but I'm just gonna write the code myself, because like nobody trusts AI, bro. Nobody trusts AI. So we're just gonna say np.mean, and then we're passing our ages, and yeah, like, see, it's making me write rubbish. Okay, np, yeah, just gonna do it like this, and then we'll say this is the mean. Okay, let's just go ahead and turn off Copilot, because like it's gonna make me code rubbish. I want to write the code myself. I don't want you to suggest code. You can't suggest Python code. It's Python, bro. Everybody knows Python, so I'm just gonna disable Copilot so that I write the code myself. It's giving me suggestions that I don't want. Okay. Then for the variance, okay, this code is correct. For the variance, let's just go ahead and print this out, and then we'll get 23 as the mean, and the variance is 4.22. Let's go ahead and just clear that to get a beautiful space to work in. Let's just throw this. Okay, so now I'm just gonna write a simple Python code to show you how you find those distances. So I'm just gonna go fast to save time. Okay, let's just say we have a distance array, which is just an empty array. What we want to add in that array, we want to say d.array.append. I think that the code that was being suggested was correct. Append, want to append this minus the mean. Okay, want to append that. Now we have this an array. We have this array now. Okay, so what do we do from here? We square every last thing that is in the array and then sum them together. So how do we do that? Because I stuck with Python, I'm just gonna write another. Just gonna do it the most simple ways, and this is like better because you guys are gonna understand what is happening in the array. Then we'll do that, and then sum equals to plus, then plus I. Then in Python to give a power, we do that, and then nope. So Copilot is not really disabled, but okay, we're just gonna work with what we have. And then now okay, they're stored in the sum, so we can just print the variance and do, yeah, I think this code that is being suggested is correct. No, it is not. We want to like divide the sum by the number of things in our ages array. Not why are we doing -1? 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. The 8 will be 8 instead of 9. So the ChatGPT code was, or the Copilot code was incorrect. So we should get two values that are equal here, meaning that we've calculated that correctly. So I'm just going to show you the data set that we're working on. Did I tell you that at the end of this, we're going to create a machine learning model that takes in this data and predicts, you see here, and predicts whether the passenger that was in the Titanic survived or not. So this is the survived. It takes in a Boolean takes in a Boolean value. So survive, it can be, if it's 0, we know that the passenger did not survive. If it's 1, we know that the person survived. And this is the class, this 1, 2, 3. This is the sex, it can be male or female, the ages of the people who were in the Titanic, how many siblings and spouses did they have, how many children and parents did they have, and then how much did they pay in to get into the ship.